Okay, for sample problem number 2, we'll start the same way. We'll try to find all of our rational roots first. So I'll go ahead and start that process. Okay, so now we have all of our possible rational roots. We have quite a large list here. So again, we'll use our calculator as a little bit of a guide. And if you look at your calculator, you'll notice that it only crosses the x-axis in one particular spot. So having only one x-intercept should give us some clues into the fact that we only have one real number solution, and the other two solutions should be imaginary. Now, quick inspection of that, it looks as if that's about a 1.5. It's crossing at 1.5, which would make our x-intercept or our root there 3/2. So we'll go ahead and set up synthetic division using 3/2. Okay, and when we finish the synthetic division, we see we end up with a depressed polynomial of 2x squared minus 8x plus 10. And we're going to go ahead and factor out the 3/2 and set up our problem so that we can finish this. Okay, and so now I'm going to distribute, or I'm going to factor out a common 2, and I'm going to redistribute that to the x minus 3/2. If you didn't go that full route, it's perfectly acceptable. And you should recognize that the x squared minus 4x plus 5 is not factorable, so we're going to need to go ahead and complete the square or use quadratic formula to solve that. Okay, and you can see here from completing the square that we get a situation where we have two complex answers or two complex roots, and we also have one real root. So that shows us a way that you could end up getting answers in a different format. Now, what you should have noticed here with the result of 2 plus or minus I is that we get two complex roots matched up with our one real root. So there's no situation where you're only going to get one complex root. This also occurs with irrational numbers. If you recall back to sample problem 1, we had plus or minus the square root of 5, which means we had two irrational roots. Again, you're never going to get a situation where you only have one irrational root. This is what we call the conjugates pairs theorem. Basically what it's saying is if you have a complex root or an irrational root, that you're also going to have its conjugate as another root to the particular polynomial. So this is something that we're going to use later whenever we're writing polynomial functions, and it's a process that you're going to want to learn. But you need to be aware, if you have a complex root, there's got to be two of them. If you have an irrational root, there's also going to be two of them.